hey, what is this happening? And here also, there are two pendulums which are colliding with each other. After collision, one is coming at rest.
Hello guys, this is Gaurav. So today I'm going to discuss about a very interesting thing which is known as momentum conservation. So students, all of you know about Newton, right? Sir Isaac Newton, who gave us three laws of motion. But the same Newton also gave us a very interesting thing known as momentum conservation. Now, what is this momentum conservation? So basically students, all of you may have seen that when you have two balls and you strike them together, they go back. If the balls are moving very slow towards each other, after the collision, they will come at rest. But the question is, why does that happen? Again, all of you may have seen a pendulum. Usually at our homes, in clocks, we see that pendulum tick, 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 like that. But have you seen how two pendulums will behave? Or how three pendulums will behave? Or how four or five and so on, how these pendulums will behave? So all these things we can identify just from a simple thing, momentum conservation.
So okay guys, here is momentum conservation. This law says that total initial momentum is equal to total final momentum. So to understand this, we will take a very simple example of two balls. Let's say you have two balls and you are making them collide with each other. So as you can see, these two blue balls, this one and this one, they are moving towards each other. This ball has a mass m1. m1 can be anything, 1 kg, 2 kg, half kg, it can be anything. Similarly, you have another ball of mass m2. These two balls have a different velocity. They are not traveling with the same. It can be same, then you can use u and u, but both are traveling at a different velocity. The velocities are u1 and u2 respectively. So this is the situation before collision. Currently they did not collide with each other. They are just traveling towards each other. Okay. So their momentum will be m1 u1 plus m2 u2. As all of you know, momentum has a general formula, mass into velocity. Our mass of first ball is m1, mass of second ball is m2. So m1 u1 plus m2 u2 is our initial momentum. Basically total initial momentum. Now, since they are coming towards each other, right? So they will collide. After the collision, there are two cases. First case, they can stop. Second, after the collision, they will move back. So, what will happen? It depends upon their mass and velocity. Let's see what is their fate. So, in the red color, you can see two balls. After the collision, now after the collision, they will move opposite to each other, right? So, their velocities I have written v1 and v2 respectively for masses m1 and m2. So, total final momentum will be m1 v1, which is for the first ball. For this ball, momentum is m1 v1. For the second ball, momentum is m2 v2. So, total momentum will be m1 v1 plus m2 v2. According to law of conservation of momentum, this says that total initial momentum is equal to total final momentum. So, our total initial momentum was m1 u1 plus m2 u2. Our final momentum was m1 v1 plus m2 v2. But wait, there is a one condition which it should follow, and that condition is the system should be isolated. If the system is not isolated, it will not follow law of conservation of momentum. Now, what is the meaning of isolated? That I will show you with the help of an example. Okay. So now you can see there are two pendulums striking with each other. If there are three pendulums, the fate will be like this. If there are 4 pendulums, the fate will be like this. And if there are 5 pendulums, which is popularly known as Newton's cradle, the fate will be like that. Isolated means there should not be any external force which is acted upon the system. Now all these 5 pendulums are moving freely, no one is disturbing them. But if someone will come and will try to disturb these pendulums here and there, then it means someone is applying external force. If external force is acting on the system, then momentum conservation will not hold. It is exactly similar example. For example, 2 people are trying to collide with each other, 2 people are fighting, but someone referee is interrupting, so referee will not make their collision properly, or it will cause a little problem. It is known as inelasticity. So basically, for momentum conservation, the system should be isolated. It should not be disturbed by anyone. Okay kids, so that was momentum conservation. I hope you like this video. Thank you.